Greetings and welcome to the PLSQL channel, a series of video trainings on the Oracle PLSQL language. My name is Stephen Feuerstein, and I'm a PL/SQL developer just like you. This lesson is part of my series on writing maintainable code, and the focus of this lesson is writing modular code with packages. Some quick reminders. If you haven't already done so, you can download all the code that I'll be demonstrating in this lesson and my other lessons from PL/SQL Obsession, which can be found at toadworld.com/sf. Let's visit. So PL/SQL Obsession has a lot of resources on it for PL/SQL developers. Click here on the demo zip link to download the zip file containing all the files that I will be using as I demonstrate the features of PLSQL. Click on Training, Seminars, and Presentations to download various PowerPoints that back up my trainings. In addition, make sure you're comfortable with the material covered in the other lessons in this series, the importance of maintainability and regression testing, the role of standards in writing maintainable code, and using key readability features of the PLSQL language. So, modular construction in PL/SQL. The most fundamental program units of a PL/SQL application are procedures and functions. These are the subprograms, named subprograms in your application. And they can execute one or more statements, and functions, of course, return a value. And if you want to use procedures and functions rather than writing enormous anonymous blocks of code, because these allow for reuse and also information hiding the details behind named program units, so that you can work with those complex structures or complex logic much more easily. So pretty much everything you're going to do in PL/SQL will be done through procedures and functions. But what I want to focus on here is the use of the PL/SQL package as a key building block for the application as a whole. And I'll start with an overview and some key features, and we'll delve into a number of detailed examples. So first of all, what is a package? A package is a collection of code elements, usually a set of procedures and functions, but they can also be type statements, variable cursor declarations, just about anything you can program or declare for use inside a PL/SQL environment, you can declare inside a package. A package is composed of up to two code elements, the specification and the body. When you write a procedure or write a function, there it is. There is the procedure or there's the function. But with a package, you have the ability to specify what the users of the package can do, and that's what the specification does for you. It describes or specifies what's possible to use in the package. Whereas the body provides the implementation of all the elements in the specification. So the specification might declare that you can write some information to a file, you can get some information back, and the package body says, here's how we're going to get those things done. Here's a very simple package. It's an example of one of my various timer packages that allows me to calculate the elapsed time of my program down to the 100th of a second using a utility called dbms utility getTime. Notice the package specification simply says capture the start time, get the elapsed time as a number, and procedure elapsed, which means show the elapsed time. Notice I have two programs with the same name. That's an example of overloading, which I will demonstrate and get into much more detail later in this lesson. So the package specification says that I can call timer.capture, timer.elapsed, or procedure timer.elapsed. And my package body contains the implementation. So I have a variable declared at the package level. Notice that this variable is not sitting inside any of my individual procedures or functions. This is called package level data. And I have the implementation of my capture procedure and the implementation of my two elapsed programs, the function and the elapsed procedure. And notice, in fact, that my elapsed procedure simply calls the elapsed function to get the elapsed time and then shows it on the screen. But the point here is that you have a clear distinction, a clear line drawn between what's in the specification and what's in the package, which means that you get to decide what of the functionality in your package body is exposed for public use, for use by other schemas that have execute authority on the package. Here's another way of looking at a package. It's called a Booch diagram, named after a fellow named Grady Booch. And it's a great way to understand the difference between public and private with PL/SQL packages. The package specification essentially defines what's publicly available. I can have public data, which I didn't have in this simple example, but I could have declared something like last timing, at the package level in the package spec. That would be public data. And I have my public procedures and functions, the things that are specified to be used by an external program, something outside of the package. Then I have the private part of my package, the stuff that's only in the package body. I can have private data, like my last timing variable right here. This is private data that cannot be seen or directly referenced from outside the package. I can have implementations of my public programs. So here are the implementations of my public procedure and public function, plus I can have my own private programs that are not exposed at all in the package specification. So again, you get to decide what is exposed for public use, what is hidden away, and you have this concept of privacy, which is a very important aspect of designing your packages and hiding unnecessary complexity from users of your programs. What are some of the benefits of packages? Well, first of all, they essentially allow you to employ object-oriented or modular design principles. You can define or build your application at very high levels of abstraction, avoiding all the underlying details. You can enforce information hiding. I don't want people to see how I implemented a certain query or a function or procedure, so I hide it in the package body, and you can't see it unless you're connected to the schema that owns that package. And I can use the packages as delivering technology to other program units. So you might be using object types, which is the object relational model in PLSQL. But oftentimes the main body of code that will be executed within an object type will be stored in my package. Triggers. I might define database triggers to fire on actions that occur on underlying database tables. But what makes a lot of sense is to hide the logic from the trigger itself, put it inside a package, and simply call that package program instead. Consolidating your logic, hiding the details, providing a high level of abstraction. Packages encourage top-down design and bottom-up construction. Top-down design means that I can define in my specification the high-level list of programs, the elements of code that I need to do, or the elements of code that represent the steps I need to take in my package. And I don't have to address the low-level implementation details. I simply specify I need to be able to do this, that, and the other. And then I can get back to the details later when I implement my package body. Bottom-up construction means that I can create a number of different packages that essentially serve as building blocks for my new code. So my packages serve as a big toolbox, and as I start to build new code, rather than writing it all from scratch, I can say, well, I already have a string function that will do parsing for me. So take the program out of that parsing package and utilize it to build these other programs. So key building blocks for the application, both from the bottom-up standpoint and the top-down approach. Packages also allow me to store my code more effectively. I have a container, a named container, in which I can put related code together, making it easier to find. And one of the great features of packages, which we'll be exploring, is implementing session persistent data, essentially global variables in PLSQL. When should you build a package? Well, whenever you have a group of logically related code that makes sense to put together, rather than have them defined as separate procedures and functions, create a single package and put all that code in the same package. There are a couple of benefits here. One is a rather physical, performance-related benefit. All the code for a package is loaded into memory together. And Oracle basically assumes that if you're going to use one program from a package, you'll probably need to use the other programs as well. So it loads them all up at the same time. That way you're not having to go back and forth between your SGA cache of code and disk where the code is actually compiled. It's easier for Oracle to manage your application code this way and can improve performance. Overall, grouping together logically related code also improves the structure and organization of your code. Rather than having hundreds of schema-level standalone procedures and functions, you can create smaller numbers of packages that collect together the related programs, like a string package or a Boolean utilities package. And then anytime I need to do anything with strings, I go and look in that package first, and if it's not there, then I think about adding a new program to the package. And I know where to put that new program. I've got a package for it. You can also improve transaction integrity by hiding data structures behind the package interface. Essentially, instead of writing SQL statements directly into your programs and having to teach individual developers how to write complex business transactions, you can hide all of that complexity inside your package body and then expose a simple program like add an order to your package specification. And it, inside the implementation, does all the individual steps of what is required to add an order, maybe inserting data into multiple tables, updating other tables, and so on. So you improve transaction integrity by not requiring each individual developer to understand the transactions, but instead put the knowledge of the transactions behind the package interface. And in general, you can construct highly flexible utilities for developers. In other words, instead of saying, here's 25 different procedures that let you do various things with strings, here's a package. Here's the string utilities package. And I've collected together in this one utility, in this one package, all the various different kind of programs you might need. It's a much more coherent approach to writing code, and it's much, much easier for other developers to take advantage of what you've written. And I'll take a look at how we can improving performance, often dramatically, by caching session data, that package level data in packages. So just to give you a couple of examples here, first let's take a look at the string tracker package. This is a package that I demonstrate in great detail when I talk about using collections to improve performance with caching. So if you haven't already seen the lesson on collections, you should definitely check that out. But in this case, I just want to give you an idea about using a package to define a clearly defined interface for utility. The string tracker package, here's the specification. It's rather small. And what I want to do is keep track of whether a certain named variable has already been used. Essentially, it keeps track of the strings I've used. Names, addresses, social security numbers, whatever the case might be. And what I need to do inside this package, or with this package, is mark a string as being used and find out if a string is already in use. So I've defined a very high-level API. This is my package spec that determines what things I want to be able to do. Mark a string as used. Is the string in use? And then inside my package body, I hide away all the details. In this case, what I'm doing is taking advantage of a string index collection to manage this information and allow me to implement the tracking of my strings very, very simply using this collection. Again, if you're not familiar with collections, and especially string indexing of collections, I strongly encourage you to watch the series on collections. I'm not going to go into the details here. But once I've got this in place, once I've defined this package specification and defined the package, then I can very easily use it without getting into all the details of, well, how do I keep track of the strings? I can simply say, clear out my list of strings. Mark a string as being used. So package.procedure, mark this string as being used. Is this string in use in my list? And all the details of how I manage the list, all the complexities of working with the collection are hidden away behind my very simple interface in the string tracker package. And virtually any package you'll write or see follows the same kind of idea. Hide the details, expose a very simple set of programs, procedures, and functions that determine what you can do, but you as the user of the package don't have to decide how you're going to do those things. Let's take a look at the employees QP and CP packages. These are examples of encapsulations, packages that hide access to the underlying tables and data structures. So rather than writing inserts, updates, and deletes whenever I need to work with the employees table, I can simply say, use my employees CP package, my change package, and do an insert, or do an update, or do a delete. And all this code is available for me in advance. It's part of my big toolbox, and I don't have to write all the underlying SQL. And this is an example of a 1-to-1 ratio between table and package, but you can also write your own packages that hide complex transactions. The point, though, is that you don't write all this SQL. Let's take a look at some of the underlying SQL. Here's the package body. Rather than writing the inserts and the updates and the deletes, I let this program do it for me. Here's my update. And I let my program do all of my complex error handling. So all the complexities of doing the right thing, really doing DML correctly, is now hidden away inside this package. And again, as a developer, I don't have to worry about the details. The employee package is an example of using session data to cache and improve performance. And I'll come back to this example when we take a look at session persistent data. But the bottom line is that you'll find yourself building many packages to create these interfaces to hide complexity, and also you'll find many, many examples in the demo zip. For example, if I just do a search on anything that ends with PK, file extensions, these are all package specs and bodies that I've created in the demo zip that are referenced throughout my trainings. So there will be lots of examples that you can look at. Packages versus standalone or schema level programs. So what I've been showing you are examples of packages with procedures and functions. Now you could also create procedures and functions at the schema level, in other words, a standalone procedure. Here's an example of a schema level procedure, create or replace procedure. This basically allows me to display Booleans by translating the Boolean value into true, false, or null strings. You could create lots of schema level procedures and functions, but my recommendation is that in general, when you're writing your applications, you should always use packages. It's a much better way to organize your code. You don't have a proliferation of hundreds of schema level objects like procedures and functions. You might have 10 or 20 or 30 packages, and each package might have 5 or 10 or 20 programs within them. But then you have a name for all the programs in that package. They're all related to mortgage calculations, or they're all related to string utilities. And that way you have a clearly defined hierarchy of code and an organization of that code. In addition, you can hide the implementation inside the package body. And the nice thing about that is as you change the implementation of your programs, you fix a bug, but you don't change the specification. You will not have to recompile programs that use that package, because programs are marked as dependent on the package specification, but not on the package body. So you can greatly reduce the amount of invalidations and recompilations you would have to do in your applications. I'd also recommend that you define small, narrowly defined packages. In other words, don't take my advice and always use packages instead of programs and then write just 2 packages, each of them having 500 program units. Well, that doesn't help you very much. What you want to do is have a lot of small, very tightly defined, narrowly focused packages, so it makes it really easy to find and maintain your code. For example, in the demo zip, I have a separate package called parse, and all this parse package does is allow me to parse delimited strings. And there are a whole variety of different kind of parsing mechanisms, and I encourage you to try out this package and use it. And therefore, if I ever have to do string parsing, I go to the parse package. I have a Boolean package, and my Boolean package contains a number of different programs to allow me to work with Booleans. Convert a Boolean to a string, convert a string to a Boolean, and so on. And I think I have a string utilities package too. Lots of different string utilities. And again, they provide me a way to very easily identify the code that will allow me to work with strings. Here's my string package. I have my between string function, get me the string between start and end locations, convert a delimited list to a collection, convert a list of clobs, or a clob that contains a list, to a collection. And again, the main idea is you create your separate packages, you give nice clear names to those packages, and then everybody knows what's available and where to find it and where to add new elements. So if my string package doesn't have what's necessary, well, rather than create another schema level procedure or function and lose it in the forest of others, I can add it to this one package. And then everybody knows, if I need to work with strings, I go here first and look to see what we've got. Some things to be aware of. Entire packages are loaded when any single program is called. This is what I mentioned before. This is a performance optimization feature. But it also means that if you create very large packages with too many programs in them together, you might have a lot of overhead in loading up that package. And if the package is not well designed, in other words, it's got 500 programs in it, and if I use program A, I might not use any of the other programs in the rest of the package because it's just too much miscellaneous stuff collected together. Then you're actually paying a price for that load of the package when you don't really need to. So you do need to be careful about how you design these packages. Also, if you have centralized packages, for example, I have one package that's used by so many other programs, almost every program calls something in this package, then if I ever change and recompile the package specification, all the programs dependent on that central package will need to be recompiled, will be made invalid. So that can be a kind of bottleneck when changes are needed. So you need to find the right balance, but the main thing is to think about putting things in the right place, creating lots of small, narrowly defined packages, and making sure that those packages contain all the related functionality. So let's look in more detail at a few different key features of packages. One is session persistence of package level data, session initialization, and subprogram overloading. So session persistence of package level data. When I declare a variable or a constant that's outside of any packaged subprogram, in other words, it's not declared inside a procedure or function, it's at the package level. And this means when I have package level data, that means that the package has state. And that state persists between calls to package subprograms. A package state means values for variables. And since they persist, in other words, I assign a value to the variable and it keeps that value between subprogram calls, they can serve as a kind of global variable in PLSQL code. Global variable can be very useful because it holds those values. I don't have to repeatedly recompute the values. But it also has some dangers because, of course, global variables can become this thing that's depended on or called all over the application and can turn things into a real mess. So I'm going to show you the value of global variables. You also have to be very careful about how you use them. And note, when you've got a stateless application, in other words, a web-based application, you cannot rely on session level variables because every time a new call is made to the back end, you might be starting up a new session or you might be connecting to a different session in your connection pool. So you can't rely on session level variables and session state. This is more for a traditional client-server kind of configuration, not web-based applications. Or anonymous blocks, jobs that run in the background, and so on. Let's just get a sense of what kind of benefit this kind of stateful application with package level data can do for you. So the employee lookup package compares the performance of querying data over and over from the database. Here's my package with my one row function that passes in the employee ID, gets back an entire row of data, and it's going to call the query over and over and over again. Well, I've realized that my table's not changing. It's a static table. So why would I go back to the database again and again and again? So what I'm going to do is offer an alternative. My employee lookup 2 package has another function with the same name. Pass in the primary key, return the record. But in this case, what I'm going to do is take advantage of package level data. I've got a package level constant called climit, which we're not really going to get into in this example. It's not that critical, but it is at the package level, which means I assign this value of 1,000 to this variable or to this constant. And it keeps that value through the entire session unless I change it or my package becomes invalid and has to be recompiled or reinitialized in my session. But then, more to the point in the example, I'm going to declare a new type of data, which is a collection, a list of records. Again, if you're not familiar with collections, you should definitely check out my series on collections. It's one of the most important types of data to work with in PLSQL. And then I'll declare a variable based on that package collection type. So this is a list, a collection of records. It's at the package level. It's not inside a procedure or a function. And that means that when I assign values to it, Oracle will hold those values in my session until the next time I need them. So what I'm going to do then is take advantage of the initialization section, which I'll come back to and explore in more detail in a moment. But at the bottom of my code, I'm going to call a program called load cache. And what this basically says is the first time each session tries to use this package, run this code, which takes all the data from the employees table and loads it into the cache. So there's the population of all the records into my cache. And then in my one row function, rather than querying the data over and over and over again, I'm simply going to return the row from that collection. Now again, the point of this lesson here is not to fully explain all the technology I'm showing in this example. You need to check out collections in more detail. But the point is simply that I'm going to take advantage of a package level list, a package level variable, to cache my data in between calls to the one row function. And each of these approaches do the same thing. You pass in a record, you get back you pass in a primary key, and you get back the record. But the performance profile of these two different approaches is quite enormous. So what I've done is create a script to compare the performance of these two using my timer package, another example of a package that provides a nice high-level API to underlying functionality. I can say start my timer, I run my code, I say show the elapsed time. And I don't have to know about, I as a user of this package don't have to know about any of the underlying details. It's a high-level utility. And I'm going to compare different ways of executing this code or querying the data from the database. And we'll just do the first two, or the two that I've already shown you, which is my associative array cache and my database table lookup. So employee lookup 2, one row, employee lookup 1, one row. Let's get rid of these others just to narrow down what we're going to look at in the results. I'll compile my package, or my procedure, which will run my package, and then we'll try it out. So what I'm going to do is run this program